Okay, so today it's about the lab 7. It's about compiling the kernel. I reckon it'll be like the shortest lab, because as you can see, it's just 2 pages. So compiling the kernel, it's not too difficult. It's not too difficult, but then honestly, it's very time consuming, because once you've configured the kernel, then you need to compile and compile everything, and it's gonna take about 4 to 5 hours. So hopefully today you can just open up your lab sheets, and then you can start cloning that the kernel from the page 1. And in the meantime, I will just discuss a little bit the concept about today's lab. I will just share the screen. Okay. So while I'm talking about the concept here, so you can just start run that command git clone switch that equal 1 and URL. Again, it's depending on your speed, internet connections. Probably at here, like at home, it took me 15 minutes, 10 to 15 minutes. It's not too bad. Okay, let's start. Lab 7, it's about compiling the kernel on Raspbian. Okay, Linux kernel. Can anyone tell me what do you know about the kernel? Like on top of your head, what is the kernel? Base OS. Correct. I think the second one, Goimer mentioned about the core of the OS. I think it's pretty spot on. It's pretty spot on. So pretty much the kernel is the central of things going on your computer. Correct. It's a core of the systems. So what does it do? Like the kernel. So the kernel, it manages the CPU resources, memory resources, and the process. So pretty much like the server, it's the kernel. It's more like a brain of your computer. A brain. Oops. Okay, just give me a second. My screen suddenly died. Okay.
Hello, I'm back. So sorry, I don't know what's going on. Can you guys hear my voice? Okay, that's good. I don't know what's going on. Suddenly, my laptop, like the screen suddenly it went off, and then yeah, pretty much I had to restart. Sorry about the technical issues. Uh, I will just open up again. Uh, okay, so again, yeah, yeah, it's what does it do? So it manage the CPU, memory, and processes. So for example, like if you turn on your Wi-Fi on your laptop, it will just call the kernel, pretty much like it will call the kernel, and the kernel will just allocate. Oh, oops. Okay. Will. Oops, 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 oops. Okay, thank you for letting me know. Okay, good. It should be good. Yep, I think we were still cool. Okay, right. So for example, like if you use your Wi-Fi on your computer, it will just call the kernel, and the kernel will allocate the memory or resources to execute the Wi-Fi. So that's pretty much like the big picture. The big picture. How does it work? Uh, I mean, like, what does it do? Like the kernel, it's a center. It's the center. It's a brain of your operating systems. And if we see the architecture of the kernel, there are two architecture of the kernel. So the first one which is the monolithic base OS, and another one which is the microkernel. So if you can see, that's the architecture of the monolithics. Sorry, microkernel and monolithics. So pretty much like the monolithic kernels, it's pretty much like all the parts is like like a file system, memory management, networking, device drivers, pretty much like all of them. It's just it is maintained by the kernel. So if you have look the stack here, like if you have look the stack here, like the monolithic, it's pretty much like it's just centralized everything. So we can say that it's centralized everything. So that's the difference between the monolithic and microkernels. Whereas the microkernel based OS here, like it's more like you can say like a distributed architecture, like so only the some important parts, like communication, memory management, and CPU, uh, and inter-process communications, uh, pretty much like they are put inside the kernel here. So if you see from the architecture here, like which one is the Linux? Can anyone guess? Like either the microkernel or monolithic kernel? Like which one is the Linux? It's actually it's monolithic. Like the Linux kernel, it's using the monolithic architecture. Yeah, so that's the one. But if you one of the example of the microkernel architecture, it is only available on Windows NT. So Windows NT is using this approach. You know, like whereas like the Unix, Linux, MS-DOS, everything here. So even like Windows 7, Windows 8, and the latest one, they're using all the monoliths, you know. Yeah, if you want to find out more, you know, like the reason why they choose like the monolithic comparing to microkernel, pretty much like if you use like the monolithic, since everything is centralized and managed by the kernel. So of course it has the advantage of the faster processing, and you know, like communications between the intercomponent, it's better because like it's centralized. Whereas like this one, definitely it has some delays because like it's different architecture. It's decentralized. So pretty much that's the approach. So I'll give you just a little bit concept about that one. Hopefully, you know, like maybe if you were asked on the exam, at least you know what's the difference between the monolithics and microkernel. And the next one would be today. Pretty much what we're gonna do. We will do like only 6 steps today. The first one, it is I just summarize everything from our lab. Summarize everything from our lab. This one. So the first thing first, if you have looked the headline, like I hope that you open your lab sheet right now. So if you have looked the heading like generate default kernel configuration, so that's pretty much like the step 1. So the step 1, you just need to create the kernel configurations, and I will explain a little bit more in the next slide. And you need to step 2, which is you need to tweak using the xconfig. So pretty much like the new kernel, like which part that you want to turn on, which part that you want to turn off, or how do you want to change or rename the kernel versions. So that's the step 2. And the third one would be the compile your kernel source. And this is the time consuming part because it's gonna take like 4 to 5 hours. Yeah, and don't forget to back up your current kernel. Yeah, it's gonna take 3 to 4 hours. Again, like this lab, it's gonna be very useful for your assignment 2 part 1, because from if I'm not mistaken, today's lab will give you like the foundations to work on your assignment 2 part 1, which is you need to compile the kernel. I think today's lab, it's, you know, like we just pretty much like we just need to clone from the Raspberry Linux kernel from GitHub, and then after that pretty much we tweak, compile, and and then we just need to copy or replace our current kernel and then just reboot. That's which is like step 4, 5, 6. But then remember, I think if I'm not mistaken, you will also have the task to do a cross compile kernel. I believe that's from for assignment 2. But yeah, I'm not too sure because like I haven't seen the assignment 2 yet. But that's our last discussion with Paul. So today's very useful. Okay, so the next one would be I will just give you like a little bit you know, like understanding about the default kernel configurations. So if you're using Raspberry Pi, yeah, pretty much. This is when I say when it is written like CD Linux, it is pretty much like a default folder that you will get when you clone that the first syntax, the git clone dep equal 1. You will see the folder Linux. So just go to the folder Linux. If you're using Raspberry 1, 0 or 0W, you need to run this command. You need to run this command. Whereas like us, we are using the Raspberry Pi 3 Plus, and later we will be running this command. And this is for Raspberry Pi 4. That's for your information only. Okay, so that's the make command. The make command, if you open up the page 2, that's where you need to compile the kernel. So pretty much here, like you can see, like for more details, we will just compile the modules and the DTBS. So pretty much just two components. So if you have looked this command, like switch J4, meaning that you assign or you give instructions to that particular command to run using 4 threads. So you can just simply change to 2 threads, but it's gonna be slower. It's gonna be slower. This is the type of kernel image that we will be using, Z image, and that's only 2 modules. Pretty much like you will be compiling all modules plus device 3 binaries, which is this one. So that's the explanations of the command. So it's just for your informations, this one. So you have the options to use the image, but it's pretty much like the old, like a generic Linux kernel binary image file, but it's just pretty old. Like we don't really use it, that one. So normally, like for a small kernel, again, we will be using this one. But again, still it's a generic Linux kernel binary. If you wanna, let's say, if you wanna try do some experiment, you want to compile your Ubuntu or CentOS kernel, yes, you will be using this one instead of this one, because the Z image, it's pretty much like for small kernel. Honestly, I haven't used the U image, but it's from my understanding, this image will give you again the additional wrapper for operating system type and loader informations. So that's pretty much for your informations. So now pretty much oh, okay, so why should I use Z image? So because of, yeah, it's specific for the small kernel. And then what are the options that you have, like here? So you have like the image, Z image, and U image. So the potential issues during compiling the kernel, hopefully it won't happen to your Raspberry Pi. Hopefully it's not. Then yes, that's really good. I was about to say that overheat. So I did that. I have 2 Raspberry Pis. I have 2 Raspberry Pis, and then hopefully I can just quickly show you. Hopefully, if you can see. Just give me a second. I have 2 Raspberry Pis. I will share the screen. Can you see this one? I've got the Nespe case, Raspberry Pi 3. So It's like a Nintendo type here. So another one which is like the normal one, but yeah, it's quite far. I cannot reach the normal one. I'm not too sure what's going on with this one, but again, like if I when I tried to compile using this Nesby case, I don't think it's overheat, but I'm not too sure because inside that Nesby case, I think it has some other components. So I can't really use like the normal or like original Raspberry Pi power adapter. I will need to use like something that has bigger output. Because during the compilations, when I'm using that Nesby case Raspberry Pi 3, it's not overheated, but I think it needs more power because I can see the lighting sign on my Raspbian desktop. So hopefully it won't happen on yours. And another issues like during the compilations, it's just suddenly crash during the compilations, which is potentially that they'll be overheat, correct? For example, like if you open up your terminal and then you do the compilation at the same time you open up YouTube, for example, or you don't really close all the applications, you just keep open and running, it might crash because I experienced that one before. And then for some reasons, if you having these issues like the boot loop, two possibilities. Like the first one, you might need to run using the lower threads. So try 2 or 3, or probably again either it's overheat or lack of power. So I'm not too sure which one, but that's the potential issues that I experienced during my compilation. So I had to compile 3 to 4 times. I mean, like 3 times using the Nesby case, and then I had no luck. And then in the end, I used like I use my my other Raspberry Pi 3 without any additional components inside the case. Like a simple, like just out of the box. That's it. So that's totally fine. So hopefully, it's not happening on yours. So if it happens on yours, then yeah, you know what's the issues. So okay. So that's pretty much like the concept and the introductions of the Lab 7. So please try and complete the Lab 7. I will switch to Raspbian, to my Raspbian. Just give me a moment. I will just switch the screen sharing. Okay. Have you guys have you already cloned the kernel sources here? Are you guys trying the lab now? Oh, no. I mean yeah, you don't really. I mean, like, oh, okay, that's okay. I mean, if you want to try this lab, you don't really have to go up to the make up to the compile command. But yeah, if you feel free to follow. Yeah, that's fine. Or you can just simply look at the demo first, and when you have time, because normally when I run I will just run the compile. I will just run the compile command, and then I will just leave it till tomorrow, so when before I sleep. Yeah, or you can do it on Saturday. Just give me a second. I will just share the screen. Share the screen. Share entire screen. Okay, so that's Raspbian. I will just zoom in. Cool. So at least you guys can read that one, not too small. Okay, so to save time, I've already cloned this one. Oops, I think I just accidentally clicked. Okay, never mind. Okay, so it will be Linux, inside the Linux. And here, I will just run the kernel 7, and make 2709 def config. So it will just generate the config file. It will generate the config file. Sorry, it's a bit slow because I believe I'm running the collaborate at the same time. Yep, it's done, and I have done that command, the next command, which is the installations of the xconfig. So what I need to do, I just need to run the xconfig here. It will load the GUI interface of this xconfig. Takes a while. That's okay. If you see like that warning, that's fine. Okay, that's pretty much like that's the xconfig. So from this exercise, pretty much you need to, just for your exercise only, you can just search the so two tasks to complete today's lab. Pretty much one, you need to change the version of the kernel, and the sound, which is like turn off the sound of your new kernel. So I will just use, rather than just go through each of this one, I will just simply use the find command here. So just type sound. So at the moment, like the sound card is support is on by default, and you just need to click that one and then turn off. Oops, turn off here. So that's pretty much like that's how you one of the example how to complete the task for your probably the similar part one of your assignment 2. Like you need to find something, and then you need to turn on or you need to turn off. So that's pretty much like how you turn off your sound card, and then you need to check from the versions here. The versions here, just double click that one, and then you just need to use this update the versions using your student ID. So in this case, I just use my ID, that one. So once you've made the changes to particular items like the versions and the sound, you just need to save and then close. It will just go back to your terminal. So once you've done that one, it's the time it's the time consuming part, which is the compiling the kernel. So pretty much just I'm using the 4 threads. It's okay, I'm using 4 threads. Hopefully it's not overheat. Modules and DTBS. There you go, pretty much. Those lists, it will just go through to compile every single code up to 4 hours, 4 or 5 hours. Maybe if I keep running the BB collab, like this screen sharing thing. At the same time, I'm using I'm compiling the source code. I think my at the moment, like my Raspberry Pi is having hard time because it's working really hard. So yeah, that's pretty much it. Like it's today's lab. It's not like something too difficult to do. You need to follow the instructions, because like pretty much like you can just have a look on Raspberry website. The Raspberry website, the documentation, they also tell you how to compile the kernel. Also, if you want to stretch your knowledge further, you can just try the cross-compile kernel. But yeah, that's pretty much it for today's lab. Yeah, that's pretty much it for me. Any questions? I hope you guys try this one. Yeah, just give a go on the weekend. I will just publish today's recording probably tomorrow. Yeah, around tomorrow afternoon. I will just publish this one. So yeah. So pretty much. So once you've done once the process is done, so you need to run the rest of the command, which is like copy the files to the boot folder. After that, after you copy to the boot folder, and then you need to reboot. So pretty much one quick thing that I want to show you. So I've tried this one. So at the moment, like it's running on the new kernel. It's running on the new kernel. So at the moment, I will just zoom in. One last thing. Oops. Is the process the same? Slightly different. But the concept is the same. So this is, I'm running the new kernel. So if you have looked this one, you will see the new versions. There you go. And actually, like at the moment, like my sound is not active. So because I'm running the current kernel. And actually, don't follow me from the previous PowerPoint. Remember to back up your current kernel in case you want to revert back. Because I think I forgot to back up mine. But yeah, as long as I can just show you how to compile, that's totally fine, and everything's working fine. Okay, so that's it for tonight. I will just call it a day if you don't have any questions. Oh, thank you. Thanks for coming. Please try. Hopefully, like you just do it once. That's it, and you won't be facing any issues like me. But if you see any issues, try to fix it. That's how you learn. Thank you, everyone, and have a good night.